Hello friends, welcome back to my channel. In the today's short lecture, we will solve a very important numerical from fluid mechanics, Bernoulli's theorem. This type of the problem is frequently asked in SSC JE and other competitive exam. Here's the question. Water flows through a horizontal pipe. At the one section, pressure is 300 kilonewton per meter square and the velocity is 2 meter per second. At another section, pressure is 200 kilonewton per meter square. We have to find the velocity at the second section and the density of the water is 1000 kg per meter cube. We use Bernoulli's equation. Since the pipe is horizontal, so the elevation term cancel out. So we apply P1 plus half rho V1 square equal to P2 plus half rho B2 square. Rearranging gives B2 square equal to B1 square plus 2 bracket P1 minus P2 bracket close divided by rho. Now let's substitute values. P1 equal to 300 kilonewton per meter square. B1 equal to 2 meter per second. P2 equal to 200 kilonewton per meter square and the rho is equal to 1000. So 2 bracket P1 minus P2 divided by rho equal to 2 multiply 1 lakh divided by 1000 equal to 200. Therefore, B2 square equal to 2 square plus 200 equal to 204. Taking square roots, B2 equal to 14.28 meter per second, approximately 14.3 meter per second. So, the velocity at the second section is 14.3 meter per second. This is how we apply Bernoulli's theorem in horizontal pipes. If you find this video helpful, don't forget to like, share and subscribe my channel Girl Civil Prep Corner. In the next video, we will solve more handwritten fluid mechanics numericals like venturimeter and orifice flow. Stay connected and keep preparing smartly. Thank you.